In this video, we're going to focus on neutralization reactions. In the previous video, we saw topics 1 to 4, definition of acids and bases. We did a brief review of naming acids and bases, but you should do most of it independently. We saw the properties of acids and bases in their table to compare them side by side, their differences and their similarities. And we also saw the pH scale and indicators. So now what we're going to focus on are the reactions that happen between acids and bases called neutralization reactions. So here we have a neutralization reaction, which is really just a reaction between an acid and a base, and it produces water and a salt. And a salt is really just an ionic compound produced by a neutralization reaction, produced by an acid-base reaction. So the general equation for an acid-base reaction is simply acid, depending which acid it is. So for example, here the acid in this example is HCl, AQ, plus your base. In the example shown below, the base is NaOH, produces water, so H2O, plus an ionic compound. So I'm just going to write this actually in words just to keep it consistent, so it's a word equation. So water plus an ionic compound, which is a salt. And the salt doesn't have to be NaCl, it could be any ionic compound as long as it's produced by an acid-base reaction. So here in this case, yes, it is NaCl, and then we have our water over here as well. So the reason that we call this neutralization reaction is because initially the acid is a pH that's less than 7, the base is a pH that's more than 7. When the acid and the base react, the H pluses and the OH minus ions combine together to form just water. So the end result is that the overall pH is 7, which happens to be neutral, hence neutralization reaction. The solutions go towards the neutral. The base goes down to 7, the acid goes up to 7. So in this example here, you'll notice it's like a double displacement reaction. The H will switch spots with the metal of the base. So the H goes where the Na was, and the Na goes where the H was. And so we get H2O, in other words, HOH, plus the salt. And to find the salt, what you have to do is the crisscross between the metal of the base and the non-H part of the acid. In this case, it's a non-metal. So if you do that crisscross, you get NaCl. So again, here we have water, and here we have salt. So a neutralization reaction is really just a special type of double displacement reaction that happens between an acid and a base. As mentioned before, oftentimes these reactants are colorless, so it's hard to tell if there's a reaction happening. So for example, if you had, let's say, NaOH and you added some phenolphthalein, it would be kind of pink. Once a neutralization reaction happens, your solutions are neutral, and so the phenolphthalein would go back to being colorless. So you could tell that there was a reaction. If you didn't have the phenolphthalein or indicators in there, it would be very difficult to tell there was a reaction just by observing visually. So just again, a little blurb about a salt forming during acid-base reactions or neutralization reactions. Here we have several examples of neutralization reactions where a base is reacting with an acid. And you'll notice each time it's very similar to a double displacement reaction. So in this case here, for example, the K goes where the H is and the H goes where the K is. They switch spots. And the end result is that we have some water produced, as well as K2SO4, which is a crisscross between the metal and the non-H part of the acid. And this is our salt. This is the ionic compound. In this case here, this is a salt, or the ionic compound that was produced by an acid-base reaction. So it doesn't have to be table salt. It could be any ionic compound as long as it's produced by an acid-base reaction. You should be able to predict the products of neutralization reactions, just like you would for double displacements. And if you're asked to balance them, you should be able to balance them as well. So just to walk you through this one more time, you circle the H of the acid, circle the metal of the base. Make the H go where the metal was, make the metal go where the H was. So you end up with some H2O. And then the crisscross between the metal and the non-H part of the acid. So you're doing a crisscross between sodium and nitrate, which gives you NaNO3. For the most part, the salt is going to be aqueous, and the water is going to be in its liquid form. Just like that. So you should be able to do the same concept for any acid-base reaction that's given to you. You can try this problem here, and then you can check your answer to my solution. So you should get H2O plus Ca Cl2 AQ. Here we have some practice problems for you to attempt with regards to neutralization reactions. You should be able to predict the products or also work backwards and see what the reactants were, complete reactions, and be able to do some communication problems. This one here looks a bit tricky. The only hint I want to give you is that it's still a double displacement, and the H you're going to be switching is this one over here. This is your acid here. This is vinegar or acetic acid, and this over here is baking soda or sodium bicarbonate. A very neat application of neutralization reactions is actually something called an antacid. So as you all know by now, your stomach releases an acid called hydrochloric acid, so HCl. And that's used to help digest your food and keep dangerous bacteria out or kill them if they do get in. Sometimes what happens though is that some of the acid, you produce too much acid, and the acid goes from your stomach up this tube called the esophagus. Because the esophagus is thin, the acid can burn it, and it causes something called heartburn. So it's not actually your heart being burned, it's acid just burning or harming the lining of your esophagus. It just feels like it's your heart because it's near the chest area. So what you can do is you can actually solve that problem. If you have too much acid being produced and harming your body, you could take some kind of medication, some type of substance to reduce the amount of acid there. So what you can do is you can take a substance called an antacid. Chemically speaking, you should be able to predict which one of these would be an antacid. Would it be hydrochloric acid? Would it be HBrAQ? Would it be MgOH2? Or would it be aluminum hydroxide? So again, think about the problem. The problem is you have too much acid and you want to neutralize that acid. So what would you use? Once you've chosen your answers, you should be able to explain why you chose the answer or those answers. So pause the video, try it out, and then check your solutions against mine. So over here you can see that I've selected A and B. The problem is that you have too much acid that's harming your esophagus. So to neutralize it, you need a base, because a neutralization reaction occurs between an acid and a base. If you take some MgOH2 or some aluminum hydroxide, which are both bases, it should help to increase the pH of the acid to bring it close to neutral. You should be able to name the acids and bases that you see in the slide here, and also carry out a problem similar to this one here. What I would do for this one is practice writing a word equation first, then a skeleton equation, and then balancing the equation. So for homework, you should do all the practice problems found within the notes and post it on the website. There will also be a little STSC assignment which you'll be given in class, and which I'll also post online that you can also get started on.